Hello, geometry people. Mrs. Saunders here, and we're starting a new unit on ratios, proportions, and similarity, all kinds of fun stuff to explore here. Now, as you watch the video, pause it if you need to, or rewind it if you need to. Just make sure you enjoy and get the information. We're going to start by defining a ratio. So a ratio is a comparison of two quantities using division. And we can express a ratio in a number of ways. We can say A to B, like just English, A to B. You can use a colon in the middle, but you still say A to B. Or what we're going to do mostly here in this lesson is use it as a fraction, A to B. As long as B doesn't equal 0, because you can't have 0 on the bottom of a fraction. So here's an example. In the 2007 Major League Baseball season, Alex Rodriguez hit 54 home runs and was at bat 583 times. What is the ratio of home runs to the number of times he was at bat? Now, before we actually set this up, I want to say the order of the words when you're talking about ratios really matters. So we want the ratio of home runs to number of times at bat. We're going to set up a fraction with home runs on top times at bat on bottom. So when we put numbers to it, we got to make sure that the home runs goes on the top and the times at bat goes on the bottom. So there's our ratio, 54 over 583. And if you want to divide it out to make it a decimal, you can. Now, the fractions, always reduce the fraction if you can. If you can't, then just leave it. But if you can reduce it, that's the proper way to write a ratio. We can also have extended ratios. An extended ratio can be used to compare 3 or more quantities, A to B to C. And one of the places we often find this is in a triangle. So here's an example. The ratio of the measures of the sides of the triangle is 3 to 4 to 6, and its perimeter is 104 feet. Find the measure of each side of the triangle. Now, I know you think, well, they're 3, 4, and 6, but those are just ratios. If the sides were actually 3, 4, and 6, well, then the perimeter would be 13. So it's a little bit more complicated than that. So here's what we're going to do. We're going to name each side of the triangle by 3x, 4x, and 6x. Now we can add all those together and set it to a perimeter of 104. We can combine like terms, so we get 13x equals 104. Divide both sides by 13, and we know that x equals 8. All right, almost done. Now we just have to plug that 8 back into each of the sides. So 3 times x, 3 times 8, is 24. 4 times 8 is 32, and 6 times 8 is 48. Those are the sides of the triangle with a ratio 3, 4, 6 that add up to 104 feet. Next up is proportions. A proportion is an equation stating that two ratios are equal. For example, A over B equals C over D. And one of the things we can do with proportions is use cross products to check them or to solve them. This is what a cross product looks like. It says if A over B equals C over D, of course, when B or D don't equal 0, because you can't have 0 on the bottom of a fraction, then AD, if you multiply A and D together, that equals BC, multiplying B and C together. We've multiplied across the equal sign diagonally. Here's an example. If 4 over 10 equals 6 over 15, that means that 4 times 15 equals 10 times 6. So 4 times 15, that equals 60. 10 times 6, that equals 60. So that's a true proportion. Let's solve a couple of these. The first one's pretty straightforward. We're just going to cross multiply. So we're going to do 2 times 8 diagonally across the equal sign and 1 times x. So 2 times 8 is 56, 1 times x is x, so we're done with that one. 56 equals x. Number 2 is a little bit more difficult because if we're going to do a cross multiplication, let's look at this part first. We're going to take the 10 and multiply it by the whole thing of x plus 22. And then we're going to take the 30 and multiply it by the whole bottom of the fraction of x plus 2. So what that looks like algebraically is 10 times the quantity x plus 22 equals 30 times the quantity x plus 2. Now the algebra skills, right? So we've got to take that 10, distribute it through to each of the parts inside the parentheses, and the same with the 30. So 10 times x is 10x, 10 times 22 is 220, 30 times x is 30x, and 30 times 2 is 60. We'll gather all the x's to one side and all the numbers to the other, divide by 20, and x equals 8. So pause the video, try the next one on your own. Okay, how did you do? So if we cross multiply, we get 4 times the quantity, 2x plus 3, equals 40. That's 8 times 5. Then we'll use the distributive property on both the numbers inside the parentheses. So we get 8x plus 12 equals 40. Subtract 12 from both sides, we get 8x equals 28, and then divide both sides by 8. We get x equals 3.5. Okay, one more in this section. Pause the video again, see how you do with this next one. So if we cross multiply, we get 4 times the quantity x plus 1 equals 3 times the quantity x minus 1. Distribute the 4 through, and the 3 as well. 4x plus 4 equals 3x minus 3. Get x equals -7. So I want to do a couple word problems here too, just to set it up once more for you. Our recipe calls for butter and sugar in the ratio of 2 to 3. If you're using 6 cups of butter, okay, that's a lot of butter. How many cups of sugar should you use? Now, you might be able to do this just in your head with what you think is common sense, but I want to show you mathematically how this works out with proportions. And again, the order of the words matters. So we're talking about butter and sugar. So let's put butter on top of sugar. We're comparing butter to sugar in the ratio of 2 to 3. Since butter came first in the sentence and 2 came through in the ratio, we know that butter kind of partners with the number 2. Sugar partners with the number 3. So if we're using 6 cups of butter and we need to know how many cups of sugar we need, we're going to put 6 on top and x on the bottom. And now we cross multiply. So we've got 3 times 6, that's 18. 2 times x, that's 2x. Divide both sides by 2 and you get x equals 9. You need 9 cups of sugar, and that's a lot of sugar. I hope you're making a lot of cookies. Okay, speaking of sugar, in a bag of red and green sweets, the ratio of red sweets to green sweets is 3 to 4. So let's just stop there and put our ratio together. So we've got red to green, and we know the ratio that they told us is 3 to 4. So we'll have red on top, green on bottom, 3 on top, 4 on bottom. If the bag contains 120 green sweets, how many red sweets are there? So we know that there's 120 green, that's going to go on the bottom, and x, the amount of red sweets there are, that goes on top. Cross multiply, 3 times 120 is 360, 4 times x is 4x, divide both sides by 4, and you get x equals 90. There are 90 red sweets. So there we go, an introduction to proportions and ratios. Thanks for being here.